Good evening. This is your exponential notation video. This should be on page 7 in your notebook, so let's go ahead and get started. A few things. Exponential notation is repeated multiplication. The base number is the number that's being multiplied repeatedly. The exponent tells you how many times to write down the base as a factor. Here's an example. 2 is the base, 3 is the exponent. So to actually write this out in expanded form would be right here as your example. 2 to the third power is actually 2 times 2 times 2, which then simplifies down to 8. Then you have a few more examples that you can take a look at. To read an exponent, so this base of 4 with an exponent of 5 can be read as 4 to the 5th power. This base of 8 and exponent of 6 can be read as 8 to the 6th power. Two special exponents that you're going to hear, so 7 to the 2nd power, or 7 squared, because it actually makes a square. I'm going to show you really quickly. To find the area of the square, you would do 7 times 7, also known as 7 squared, because it makes the shape of a square. Same thing with base of 5 with a 3 as an exponent. You can read it as 5 to the 3rd power or 5 cubed. So any exponent of 3 means cubed. Again, similar to the square. The reason why it's called cubed, 1, it makes a 3-dimensional shape, and then 2, a cube has all sides the same, and when you find the volume, you do length times width times height, or base times width times height, however you want to call it, and this would be rewritten as 5 times 5 times 5, which is 5 to the 3rd power, or 5 cubed. So that's where they get the names from. All right, going on the inside, you guys learned about base 10 last year. If you look at the following, 10 to the 1st power is 10, 10 to the 2nd power is 100, 10 to the 3rd power 1000, so on and so forth. So if 10 is the base, here's how you find the answer. You write a 1, look at the exponent. The exponent tells you how many place values to move the decimal. Okay, so for example, if I had 3.4, and I think last year your teacher might have said how many zeros you add, and I want to fix that because it's actually how many place values you move, because every place value of 10, you move it to the right. So 3.4 times 10 squared would not be 3400, so it would not be 3400, it would actually be 3.4, and you move it twice because you're moving it 2 place values, so it'd be 340. So I just want to clear that up. All right, so now we're going to do a little bit of practice. So right here, you have a base of 4, because that's what's being repeated. 1, 2, 3, 4, 5, 6. So this would be 4 to the 6th power. 3 times 3 times 3. The base is 3, and we wrote it 3 times, so to the 3rd power. 1, 2, 3, 4, 5. So the base is 2 with an exponent of 5, because remember, exponent is repeated multiplication. Next, we're going to simplify the following. That means to actually find the value of it. So 5 to the 3rd means 5 times 5 times 5, which gives you 125. 4 times 2, or sorry, not 4 times 2, 4 squared, or 4 to the 2nd power, means 4 times 4, which gives you 16. And then 10 to the 6th power means 10 times 10 times 10 times 10 times 10 times 10. Which then gives you 1 million. All right, moving on, some exponent practice. But this time you're going to remember your integer rules. So if you go back to page 6 in your notebook, we talked about multiplication and division with positive and negative numbers. So please look back at that, at your rules. I'm going to remind you with my little smiley faces. Positive times a positive is a positive. A negative times a negative is a positive. But a positive times a negative is a negative. All right, so this means 2 times itself twice, which gives us 4. This actually means, okay, so I'm going to kind of talk about this one, and I want to zoom in. So this is actually, it gets tricky. So this exponent is actually just on the 2 and not on the negative. I know that sounds really weird, but this one over here, the exponent of 2 is actually on the whole negative 2. So this is actually negative 2 times 2, because again, the exponent is only on the 2 itself and not the sign. So then you have negative 2 times 2, a negative times a positive. That's right over here, so that gives you negative 4. This one is different because remember, parentheses allows you to include everything inside. So this means negative 2 times itself. Okay. Now we have negative times a negative, which gives us a positive. So this would be positive 4. I know that's very tricky. So just remember that in order to show that the whole number with the sign is being squared or raised to an exponent, it has to be in parentheses. If it's not in parentheses, the exponent is just on what's next to it. All right, number 4, this is 3 to the 3rd power, so that just means 3 times 3 times 3, which gives you 27. Again, same as number 2, so we're going to write this as negative, and then we're going to write 3 times. 3 times 3 times 3. All right, a negative times a positive is a negative, so that's negative 9. And then negative 9 times 3, that's a negative times a positive, gives us a negative 27. This one is just like number 3. It's in the parentheses. So that means we're going to write the parentheses with the negative 3 inside twice. And remember, parenthesis beside parenthesis that just means multiplication. So a negative times a negative gives us a positive. So this would be positive. Oh, my mistake. Sorry, I was supposed to write that 3 times. So negative 3 times negative 3 gives me positive 9. Positive 9 times negative 3 gives me negative 27. We actually end up with the same answer for these two, but not for these two. It will always happen like that for odd exponents, and this will always happen for even exponents. All right, let's go over here to the independent practice. So again, 16 to the 2nd does not mean 16 times 2, okay? It actually means 16 times 16, and 16 times 16, I think, gives you 256. Oh, I could be wrong, hold on. Yep, 256. (11 to the 3rd power just means 11 times 11 times 11. And that gives you a very large number, 1,331. Okay. I'm going to let you finish the rest. Just remember that with a negative number, so an integer, just make sure that if you want all of these to be repeated, you will have to write it as such. Okay. So this is not the same as negative 8 to the 5th. All right, well, good luck, and hopefully tomorrow during class you can ask me any questions. Thank you.